your friends.
I did. Not.
On
God, I did.
Somebody's day.
No.
And I think I told you this, maybe I didn't. We always give part of our proceeds to the Leukemia Lymphoma Society. And so this year it's in honor of Mrs. Kavanka.
They didn't tell us that.
Well, now I'm telling you that.
It's too late now.
No, it's not.
No, it's not.
I don't. I have the money today. I won't have it tomorrow.
Well, we have it tomorrow. Find some. Have it tomorrow. Tomorrow is the last day.
Wow, you can't save your money.
All right. So now we're ready for problem number 9.
I'm unemployed.
In which quadrant is an angle whose cosine is negative and whose sine is also negative?
Fucking 3.
3.
3.
Has to be 3 because cosine is x and sine is y, and we want them both to be negative, and that only happens in quadrant 3. Find the exact value. So that means no calculator, right? I know you have a button on your calculator, but this is no calculator. We want the exact value. So, see that notation right there? This is what you were asking me about earlier, Grace. See that notation right there? That means negative number, that notation, I'm in quadrant 4. And I need the sine opposite over hypotenuse to be negative root 3 over 2. So now I know the angle is 60. But don't say 60 because you got to be in quadrant 4. So what will I say instead? Negative 60 degrees. Or it doesn't tell me. If I have to answer it in radians, it would be negative pi over 3. Right? And it would have to tell me that for me to know that. Okay, find the value. This is one like Joe asked about. Joe asked about a problem just like this. It's a no calculator problem. Where do I start?
The first quadrant.
I draw a triangle in the first quadrant because that's a positive number. And opposite over adjacent is 3/4.
Yeah.
Then I finish the triangle. So 3 squared, 4 squared, add them up, square root of.
That's fine.
It's going to be 5. And then I want to know the cosine. So the cosine is 4/5. It's kind of easy. All right, number 12. What is the period of the first piece of the equation? Let's see. The period of the first piece of the equation is 2 pi divided by 1/2, which is 4 pi. What is the period of the second piece? 2 pi divided by 2/3,
3 pi.
which is 2 pi times 3/2, that's 3 pi, yep. They don't match, so it's not sinusoidal, but it is periodic. So this one repeats every 4 pi. So 4, 8, 12, 16, and so on. This one repeats every 3. So as soon as I get a match, I'm done. And right there it is, right? So what's the period? 12 pi. All right, Charles is perched to the top of a tree that's 32 feet tall. These are all calculator problems now.
So Miss Ward?
Yep.
I saw in one of the other questions there was a subtraction instead of plus sign. What difference does that make? Does that find the period of the two equations?
Doesn't have anything to do with anything.
It doesn't.
Because all I look at are the periods of each piece. All right, So we got a tree that's 32 feet tall. His angle of depression is 23 degrees. How far, here's Charles on the top of the tree. Here's the book on the ground. How far is Charles from the book? Where's X?
I thought.
It's 10.
No, it isn't.
Oh, no, it's not 10.
X.
Sorry.
It is
No, it's
Sign.
Are you sorry?
Sine.
Yeah.
Sine 23 equals 32 over X.
X equals 32%.
So X sine 23 equals 32, and X will equal 32 over sine 23. Now that is a degree measure, so I know we've been switching back and forth. I don't know, yep. It'll change 2 degrees. And then 32 divided by sine 23, I got 81.90 feet. Okay. A ship sails from port on a course of due west. Alright, so I'm gonna get my compass out and look at it.
How does this look?
And remember that, I don't know if I need to label any angles here, but if I do, let me see what I've got. I've got north, south, east, west. So here's port, here's my ship sailing due west, okay? At a speed of 4 knots. 4 knots, nautical miles per hour. 6 hours later, all right, so wait a minute, he was doing this for 6 hours. Agreed? 6 hours, 4 miles an hour, he went 24 miles. Then he turned due south. For 2 more hours at 5 miles an hour, so that's 10. Here's where he started. He went west and then south. Now he's right here. At this point, what is his distance and direction from port?
Pythagoras.
So,
That's right.
since it was west and straight south, isn't that a right angle?
Yep.
So his distance will be the Pythagorean theorem, which is something. That was an even one. What is that? Is that 26, I think?
Yeah.
24 squared plus 100 square rooted. Yeah, that's 26. So how far is he from port? 26 nautical miles. That's how far he is from port.
Wow.
What?
It's a bit like off the top, or off, not math, but like what's the difference between a nautical mile and just a.
I explained that, didn't I?
No.
I didn't?
No.
Okay. So, have you heard the word knots before?
Yeah.
Yeah.
All right, and when do you hear that? Do you hear that? I'm gonna
Airplane.
get in my car and drive 48 knots.
Yeah, I hear that.
No, you don't hear that. When do we, when who uses
Airplanes
knots?
and
Planes
boats.
and boats, and space shuttles, and things like that. And why do they have in common? They are traveling great distances, okay? So here is the Earth. That's the whole Earth. Here is Cathedral High School. Here is Lisa Ford's house. So I get in my car and I drive to Cathedral. I am on the Earth, but the Earth is so huge and my distance is relatively so small, that is a straight line. By all intents and purposes, that's a straight line. Would you agree with me? But if I say I'm going to Australia, then there is no straight line. To get to Australia, I'm going to have to go around the curve of the Earth. The bigger the distance you travel, the more curvature you have to deal with. Okay? So we have the miles I drive to school, these little straight lines, those are called statute miles, land miles, 5,280 feet. Nautical miles are measuring the distance on the arc, which is greater. I think it's like 6,080 or something like that feet per nautical mile. But that's why we have the two different units. If you are flying in an airplane, your speed is measured in nautical miles per hour, a knot. If I'm driving downtown, I'm measured in miles per hour, regular miles per hour. Okay, so it's handled exactly the same, but if your speed is measured in knots, then your distance is nautical miles, which are bigger than regular miles. Okay. All right. So yeah. So this is just 26 nautical miles. So it's like 26 miles. Okay. Now, his direction would actually be this angle right here. Because remember, in navigation, our measurements are from due north. So, could I possibly find this angle right here? That will not be my answer, but can I find it?
Yeah, 3 different ways.
Huh?
3 different ways to find it.
Exactly. I could use sine, cosine, or tangent. So maybe I would say tangent x equals 10 over 24. How do I type that into my calculator?
Okay, -1.
Yeah. If you are looking for an angle, I don't know how else to say it. If you're looking for an angle, you're going to use those buttons. So what is that angle? Second tangent. Am I in degrees or radians? I'm in degrees, okay. So second tangent, 10 divided by 24, 22.62. So this angle right here is 22.62.
You say negative?
No. In navigation, we don't have negative angles. All right? So what is my actual answer then, which is the green one? What would that one be?
270.
Yeah, now this time you are gonna use 270, because you're using this line, which is the 270 line in navigation. So it's 247.38 degrees. So if you told a helicopter to leave port and fly on this course, that's exactly where he'd go.
What happened on the airplane was?
All right. Robbie is walking at a pace of 2.5 miles an hour toward the Algebra Scholars Building. At one point, his angle of elevation to the top of the building is 54. After 30 minutes of walking, his angle of elevation is 62. How tall is the building? So, think about what's happening in the problem. This is going to be a little bit more complicated. So here's my building. Here's Robbie. Robbie's coming this way. At some point, he looks up at the top of the building and his angle is 54. But he keeps walking and then he looks up again and his angle is 62. Okay? Now, there is one more thing you know that I don't have labeled. One more thing. Can you tell me what else I know that I haven't put in to my picture?
30 minutes.
Patton?
2.5 miles. I mean, you can find out the miles of travel.
Exactly. I know that he's walking 2.5 miles an hour, and he walked for 30 minutes.
1.25.
So this distance right here is 1.25. Does that make sense to everybody?
You said it again.
Help him out. Thank you, Jay. All right? Okay. Thoughts on how to proceed? This is one of the ones that's a little tougher.
You could do X minus 1
Could I call this right here y? And I could say tan 62 equals x over y. Now that is not solvable, it has too many variables, but is it a true statement? And then if I look at the whole triangle, I could say tan 54 equals x over y plus 1.25. So we had one of these the other day. What do I have here? What is this? A system of equations. I need to substitute or eliminate. My personal favorite is, can I get x by itself in both of these?
Yes.
And then set them equal to each other. So x here is gonna equal y tan 62.
Yeah.
And x here is gonna be tan 54 times y plus 1.25.
Yeah.
So since those are both x's, I can say y tan 62 equals tan 54 y plus 1.25. I know there's a lot going on in that equation, but it isn't hard. Now I distribute. Remember, tan 54 is just some kind of decimal, so it distributes. Y tan 62 equals y tan 54 plus 1.25 tan 54.
So try with y tan 54.
Yep, yep. You're doing great. Now I'll put all the y's on the same side of the equation. So y tan 62 minus y tan 54 equals 1.25 tan 54.
Back out the y.
Yep. And divide, exactly. So y is going to equal 1.25 tan 54 divided by parentheses tan 62 minus tan 54. So make sure you're in degrees. We are. I am. When you type this in, the minute you type tan, it's going to put a parentheses. You're going to put in 54, but then you have to close that parentheses, divided by another parentheses, right? So let's see if we can type it in.
When you type it, and it goes, and you say parentheses, and then it shows another parentheses, you close that parentheses.
Now, my numerator's not in parentheses. There's only going to be one parenthesis.
No, I like
there.
the denominator.
But there's going to be more down there, yeah? You have to close it after every number.
Alright.
After every number, you gotta close it. I got 3.41.
I did 3.
Anybody else get that? Yeah, that's all exciting and good and all, if there's a bit of a problem, that's why.
Cool.
And I wanted x, but that's easy. X is y times tan 62. So I'm just gonna take this number right here, times tan 62. Well, you can tell I made up this problem. The building is 6.42 miles high.
Wow.
I know.
Skyscraper.
That's what happens when I make up
35,000. No, it's not how it works.
Alright, two more. Two more. And then we'll decide what we're doing about a test. Find the angle of depression of a goose that is 50 feet above the ground. He's coming in for a landing, and the pond is 198 feet from the goose.
So plot is, give me that.
And we are finding the
Sign.
angle.
So it'd
So
be,
sine x
and then you get sine
equals
negative
50
one,
over 198.
sine negative one,
Sign.
And then inverse sine 50 over 198. And that will be, if I'm using my calculator, I don't need to worry about quadrants. It takes care of all that.
or degrees.
14.63 degrees.
Yep.
And that last one now, we're gonna do with no calculator. I know I have it in the calculator set, but it is a no calculator problem. So we're gonna do that last one without a calculator. Alright, so we've got, this is 105, radius is 4. Ooh, tricky. This is,
Yeah.
That's not really tricky enough.
Yeah.
and
Yeah, it is.
this is the arc. But the shaded area is the outside part.
So we gotta find the inside part.
112.
Well, let's not do 105 over 360.
Mine is.
Let's do, what is it, 255?
Yes.
Yeah,
Let's do 255 over 360, because isn't that this actual angle here?
and then what'd you do for 16 pi?
Times,
Or yeah, 18?
what's the whole area?
16 pi?
16 pi.
Here we go.
Alright, so here we go. You'll have a little calculator to help you with arithmetic. Let's see, 5 goes into there 51 times. 5 goes into there 72 times. 4 goes into there 4. 4 goes into there 18. 3 goes into there 6 and 17. 2 and 3, oh Lord. I'm getting 34 pi over 3. I'm gonna double check that on my calculator. 255. Yep, 34 thirds. So that's the area, so that would be square centimeters. Okay, so don't, if you're getting bogged down in the arithmetic, that's on you. You understand the setup. We want the big shaded area that's 255 degrees, so 255 over 360 times the area of the whole thing, which is pi r squared. Now, how are we gonna do, now this we want the short arc. We want that arc. So what are we gonna do to find arc length?
Radius times
Radius times radians. So we're gonna need to get that angle into
radius.
radians, but that's easy. Pi over 180 equals something over 105.
7 pi over
105 pi over 180. I don't know, is that what it is? 15, yeah, 7 pi over 12. That's your radian measure. So your R will be that number times your radius, which is 4. I got 7 pi over 3 centimeters for my arc length. Radius times radians. Let's try it again. Unless I made a mistake. I think I did. Good, I don't see it. All right, So here's the deal. We have another day to keep up, to be with the other classes. You can take another day, but what does that mean? That means your test is next Tuesday. That's what that means. Because tomorrow we can review again tomorrow. I don't see a Friday. We're off on Monday. Our test is a Tuesday. So I'm okay with that. I'm totally okay with that. If you're okay with that. Now, another thing we can do is on Friday after school, if anybody wants to come and take it on Friday after school and then not have to worry about it over the weekend, that would be another.
Will you grade it if we do that? Will you grade it by the weekend?
I don't know. I mean, I don't know.
Hey, give her a break. Look at the over under Sunday morning.
Okay, so, is that feasible for everyone?
You like that? Yeah, I like that.
You still walk in 30-degree weather? You still do that walk?
Not that big of a deal, I just
in 30-degree
wanted to know.
weather? You still do that walk in 30-degree?
No, once you start moving, you don't even know it's 30 degrees.